Hey guys, sorry that you're absent if you're watching this video, but I'm going to go ahead and make a little recording of simulation of what we did in class so that you're not falling too far behind. So if you're watching this, you saw that there's something we're adding to our notebook, which is going to be called poison or not poison. So the point of this investigation is to see, can we use physical and chemical properties to figure out if two different substances that look very much alike can be differentiated? Can we tell which of these two cups is poisonous and which one isn't? So take a close look. One of these is perfectly safe to drink. The other is poison. So even if I swirl them around, they look pretty much the same. Look at the color. Does it look like either of them have any color? Probably not. So color is an example of what we call a physical property. It's something that we can observe from a substance that doesn't affect the actual substance. Like we can observe it without changing the substance. Can you think of any other physical properties that we might observe just by looking or observing these liquids? So we had some suggestions in class. Somebody said, maybe we could smell. If one of these is poison, I don't know that we want to smell it, but maybe you could waft each of the liquids. Remember, wafting is where you take the smell and you bring it to you. So let me waft. Nope, don't notice much of anything. Let me try this cup over here. I don't really see much of anything either. So we can use our senses in order to get an idea of what might be poisonous and what isn't. So smell, that's something we could do. Maybe hearing. Let me listen. It's really quiet in here right now, so you guys would hear fizzing if there was any. I don't hear anything going on, so that wasn't very useful. So used my nose, used my ears. I could taste it. Probably not a good idea if it's poison, so not gonna taste it. We could, if the instructions were to say that it's safe to do so, but that's the last resort, guys. Don't ever taste anything in the science lab unless you have permission. So what other senses do we have? Touch. I don't know if I'd want to dip my fingers in here because if it's poisonous, there is a chance it might burn my skin. So we could touch other substances like the table. Well, we call that texture. So sometimes with different materials, we can touch and feel what the texture of substances are. Sometimes it helps us identify it. Like glass would be really smooth. Our tabletops are kind of smooth, but not as smooth as glass. So that would be another example of a physical property that we could observe. Now, that leaves us, let's see, we got our nose, we have our ears, we don't want to taste, we use hands. Sight. We looked at these, they don't have any color, and you can kind of see they both flow around the same. It's not like one is thicker than the other. We could call that viscosity. And I know it's a little hard to tell because the plastic cups themselves aren't really clear, but both liquids are pretty much clear. It's hard to tell the difference between the two. So that's clarity. Clarity is another physical property that we could observe. So maybe physical properties aren't going to be too useful for comparing two liquids that look so similarly. We may use what would be a chemical property. So in class, in order to see if we could differentiate between these two liquids, we tested reactivity. Do either of these liquids react to another substance? So that is what we're going to test. So in this bag, I have something you may be familiar with. Some of the students in class today knew what this was, and that's yeast. Yeast is used in baking. If you add it to dough, it makes the dough rise and it makes it spongy, kind of like sandwich bread or cake. If you don't put yeast in stuff, sometimes it ends up being really flat. You can imagine like a tortilla. You don't want a birthday tortilla, you want a birthday cake, right? So yeast is going to help that happen. So what I'm going to do is I'm going to add some yeast to both of these cups, and then I'll hold them up in front of the camera for you to get a better look at what's going on. So which one should I start with? I'll start with this one. So I'm going to pour in some of the yeast here just to cover the top. like so. You see that? I'm going to go ahead and just stir it around. Hold this up for you guys. Oh, it doesn't look so clear anymore. You can see some of the stuff, some of the yeast clumping up in here. So it's not as clear anymore. That could be the yeast mixing in with the liquid. Let me take a smell. I think I smell something going on. There's a change in smell. Let's go ahead and pour some yeast in the second cup and see if anything different happens. So I'm pouring just enough yeast to cover the top, like the other one. I'm going to go ahead and swirl it around. Oh, and this one's doing something a little different. Let me hold it up for you guys. It's definitely cloudier than the first one. And I don't know if you guys can see, but it's starting to get a little foamy on top. You guys see that? This one, it's just pretty much stayed a cloudy liquid, but this one is getting a layer of foam up here. So let me kind of bring this down a little bit so you can peek inside. Hopefully you can see there. We're getting a layer of foam. So that means that a chemical reaction is occurring that is producing carbon dioxide gas. And if I waft this one, ooh, there's a really strong smell. It almost smells like bread baking. So we can use maybe not physical properties, but testing a chemical property to figure out which of these probably isn't safe to drink. So this first one that didn't react very much with our yeast is water, which is H2O. We learned that last week. So this liquid, this is the one that's poison. If you were to drink this, you probably have to go to the hospital right away, and there might be a chance that you wouldn't survive that. This is H2O2. This one has two atoms of oxygen in it. This is called hydrogen peroxide. Sometimes they use peroxide to clean cuts. So right away it goes and it kills living material. Yeast is a living material. So it's reacting with it to produce these bubbles, which is carbon dioxide gas. This is an example of a chemical reaction. So this is the one you definitely would not want to drink. So if you guys can go ahead and copy down what I'm going to put with this video into your notebooks, if you have your notebooks, at least you'll be able to keep up with what we've been doing in case you come back tomorrow. If you're out for a few more days, I'll try to add things, throughout the day so that we don't fall too far behind. Okay. Well, thanks for watching. Hope you feel better if you're sick, guys. And if you have any questions or you have any comments, you know that you can always put those in Google Classroom. All right? Take care, guys. See you soon.